Hi guys, today I'm going to show the additionals what I have done this 1-2 months. Okay, as you can see, these two are new. So these two are the same models. The MPPT charger are the same models. This is the original, the last few videos. I have 6 450 watts solar panels going into this one. 3 in series, 2 parallel. So there's a 2.7 kilowatts going in here, and this one I have another 6 panels of 525 watts each going into this 3.15, also 3 series, 2 parallel, and these are all the same. It's a 900 watts grid tie inverter. So now I totally have 2.7 kilowatts, the kilowatts grid tie inverter. Okay, this is new. So this was added a few months later than this one a few months later, because I feel that I need a little bit more, or 2,400 watts. So this is 2,700 is even enough to cover. So now let's zoom into, these are all silicon cables, charging silicon cables, and I've used this circuit breakers to do it. These I have to change. I have the bus bar here. Bus bar. These are the bus bar with the fingers. The fingers will go directly inside here. So this is allowable for 100 amps. So it's well enough for them, for the grid tie inverters. So then these are new. The blue ones are new. I got one spare. So maybe another grid tie inverter here, which not so soon, probably not so soon. Then the sensor meters and the switch for all grid tie inverter going to this. Then this goes right into the incoming. Incoming is here. So let me explain from the incoming. It's much more easier to understand. So let me change hand. This is the incoming. But incoming, then I have a surge protector and a meter, internal meter, my own meter here. This is the internal own meter. Surge arrestor is just MOVs and temperature fuse. So it goes here. Actually goes here because of the wall. You got no choice. It's better to put it this side. So this one this is a automatic cutoff for low voltage and high voltage. Low voltage and high voltage. So the brown out and surge will be cut off by this one from the mains if I'm not using any solar. Okay, then it goes into the transformer. This is it's a transformer to actually lower the voltage by 10%. So I usually got now is 241. 241, and let me zoom in to show you guys. 241 here. But after the transformers, it goes into this side of this is the ATS, automatic transfer switch. So ATS. So now it's 241, but you can see here at the meter. This is the meter. I'm having 213. This is the works of this transformer. It lowers down voltage a bit, so I have more spare rooms for any surge or what, because the surge might went through this also. Then let's get back. ATS comes out. This is a sensor for this meter. So like this, I have to manage the wire more a bit. I may have to wind it like this. Wind it like this, then the protector. Then so the normal power, so-called the normal side, normal supply, comes into the ammeter, hertz and voltmeter. Hertz, of course, is important. Hertz. Ammeters is for me to see my compressors, air cons, and all that, how they function, any jumping or too much or whatever. If this I can see here something is wrong with the consuming too much power, too much amp, that means the compressors need to be serviced or something. This I can sense it out. So this site is actually an isolated system for my Wi-Fi. Totally is the charger going to the voltage sensor. So with connectors to charge and cut off the charge. This is a 24 volt batteries, 24 volt 20 amp batteries. Then it's converted down back to 12 volt 3 amp to supply my Wi-Fi. So this one keeps cycling every day, cycling 2 times. So it is a UPS. You can use it as a UPS, but this is all DC. All DC side, only this one is AC side. Totally separate from the solar system and the main power systems. So they come back to this one. After getting this tree, actually it goes through the internally, it goes through the emitters, then goes right back into this protector, then goes to the house. The hertz and the voltage is just parallel off because before all these things been installed, this protection, sometimes the voltage just swing around, so I just have to monitor a bit. But now it's okay already, probably okay, all okay. Then it goes into the house. So this part is from the mains. Then how the grid tie inverter goes in. First is the sensor over this side coming in. This is the incoming live, the black color line, incoming live. So the sensor roots back here, roots back here. Then there has a communication RS485 back to all 3. This is the communication, all three to command them to give how much power to tie in. So all the AC side from this one cut in, this one goes in here, goes into this switch. This switch also switch on and off the grid tie inverters. So this blue color line, the thick one, this is a thick one, much thicker than all this thing, because this carries 2.7 kilowatts at max. Goes back to the, it must be above, in front, we call in front of the sensor, goes back to the normal side, which is the green color, like now, then goes into the house. So this is the grid tie inverter side. I have another off-grid inverters when there's power outage or there's so much sunlight. I use the off-grid inverters. That's this one. This let me open it. There is this one. See? This is a 3 kilowatt off-grid inverters. I wire it this way instead of using the plugs. The plugs I not feel so good, so I open it up and solder a big wires inside. So let's go through this, how this works. First you must come here. The two charger, the MPPT charger. So I have labeled them MPPT1, MPPT2. This is 2 battery side. Battery. This is from the solar panels cut off. So it goes through these 2 big wires. I can consider this as bus bar. So the MPPT1 just go through, and using this style of connectors, it's a solid brass connectors inside. They connect two MPPT charger together. You can see it connect this way and this way. So I don't heat up at the terminal side. It might heat up because this one I've tested over 100 amps going through this cable at this point. So at this point is better because this is solid copper. Then going through this point, you will heat up. Then joining this, no. So that's why I do it this way. Then these 2 cables go down to the battery cabinet this side. This is the earth surge. If there's any surge on the DC side, this is a MOV again, DIY MOV. It goes to the earth. So I wrap it up properly, so the pads doesn't really harm it anything. So this one goes to the battery cabinet below, coming up. Then Then at the other side I'm using these terminals also. So all the batteries, and this one is the capacitors, surge capacitors, all the batteries are connected to that large cables using that connectors, the type of connectors. So I might have to do something about this first. Then at the end of it is capacitors and this off-grid inverters. These off-grid inverters, I've used this type of connections. This type of solar connections. Back live and neutral. Go back to the here, comes up here, and go back to the this side, this side to the secondary supply of the ATS. So when AC incoming is not there, is stopped, is cut, it will goes to the automatic goes to the secondary supply. If this is on, so I could usually can switch it over anytime. The reason why I'm doing this is because Vietnam have rainy seasons. So if there's a rainy seasons and the power outage is cut, and my battery is low, very rare. I have not gone through any situation like this, but it's just a preparation. So I can plug in my generator this side. Totally, this system is not up. I have to unplug. When I unplug, I know. Then my generators could go in this side as a secondary supply. Again, I have a small generator, so it's a backup plus backup. Grid tie is normal usage. Off grid is for surge and power outage. But I do cycle them. This grid tie inverters and off-grid inverters, I cycle them 12 hours per day when the battery is fully charged. So I give the grid tie inverters enough to rest, totally cool down. So this is basically my systems, and my this month I have additional import only 35 kilowatts. Before any installations of my solar panels and solar system, my monthly kilowatts is 450, about 400 to 450. So now I import only 35. I import only 35 here. So it's over 95%. Over 95% savings. So then this is additional also. I wrap them up because instead of a lot of cables, I just see a big cable harness. Then the wires, these wires, I have these wires. I'll show you. Let me show you. Okay, you can see here. This one. This one and this one too. This one too. And why is trim? Instead of using a ferrule, buy a ferrule, I buy a whole copper strip, cut it up, and roll it on the ends of the cables, all. Then clamp it in. It's much more tight. It's much more tight. So a bit about the batteries. Now a bit about the batteries. These batteries are Narada 48 volts NPFC 50M. So it's 2.4 kilowatt hours per battery. I have 4, so it's 9.6. I might have add one more or two more. I'm not sure yet. Let's see later. As you can see, they have communication cables, and this is the ID. Like I said, this one is master, slave 1, 2, 3. But I didn't plug in the communication cables because somehow I find if they are not plugged in and this master is not controlling the others, because when this master is controlled, it will charge up the master first, then the next one, and the next one. Of course, they charge at a lower rate than the master. This is the controls, and they will randomly charge up different ones every day. First, as the first batteries to charge up. Of course, the master must be charged up, and the master will last to drain. This is the I program inside. But somehow I didn't like this configuration, because this battery seems like it's old. Storage batteries is a bit old when I bought it. Maybe it's old stocks or what. So it charge up faster than others. When the master is controlling, this one charge up really fast. So I'm afraid it heat up the heat inside. So I unplug the network cables. Then they all run as individual and work together. They'll be charging together. Then this one will charge a bit slower. Of course, extending the battery lives. So I bought it two different times. This having a different version, but they works. They do works. This one with the switch, master on-off switch. This one doesn't. It's pretty easy to switch it off. Just press and hold for I think 5 seconds, or until the LED all switch off. It will switch off. For this one, it's just a flip of the switch. So this thing is quite heavy, pretty heavy. Then that's all about the batteries, and this whole thing is housed in a network cabinet. This is server cabinet, a computer cabinet. Then with the fans, there's a two exhaust fan here. I didn't connect this. It doesn't need. All the batteries are cool, and the off-grid inverters are cool. This is a pure sine wave off-grid inverters. Pure sine wave, locally made by Vietnam. To me, it works pretty fine. 3 kilowatts for me is pretty fine for the daily use. Except for I cannot use two big consumption items together, like an aircon or microwaves. So I have to toggle between them if I'm using this off-grid inverters, which is pretty fine. We don't usually cook. Just 2%. We don't usually cook. If we cook, then we just be a bit careful about it. Even if you trip, just switch off the microwave, and you automatically comes back on when the fault has gone off. So really nothing to do much about this grid tie off-grid inverters. So that's about it for my system, my whole system. I'll put a bit of the link, a bit of videos on the installation on the my new solar panels, new 6 solar panels. So the next video, I'm going to install the bus bar onto this side. Okay, see you guys. Thank you. Now building the phase 2 solar. I'm gonna build here because this side is south. So solar here is a water tank and solar water heater. Here we'll put 6. So you can see. I put 6 today, but I saw 6 more. So it's 5.7 kilowatts. More than enough for us.